This is Jerry Tickler with Elford, a construction manager here in Columbus, Ohio, and I'm really excited to introduce Scott to run us through a introduction to MEP Fabrication software. So from the construction management side, when we're going through doing building coordination using BIM, we're essentially taking the design team architectural model and we are remodeling the MEP inside that architectural model, and then we can take the fabrication models and take them, depending on how closely we think we got it, we can export that out, straight out to fabrication. So I'm excited to see what Scott can show us and help everybody take it to the next level of detail. So Scott?
All right.
You want to take it from there?
Thank you, Jerry. So yeah, I'll go ahead and get started. So thanks for joining us today. We're going to be taking a look at some of the Autodesk MEP fabrication workflows. And my name is Scott Buchanan. I'm a subject matter expert here at Autodesk. And I am fighting a cold, so there may be a bit of clearing in my throat and things like that. Regular cold. I'm just regular sick, by the way. So, but a little bit about me. So I've been with Autodesk about 3 years now. And prior to that, I was with a very large Autodesk partner doing implementations of all the MEP design, fabrication, and plant solutions. So traveled North America quite extensively building those out. And then from a kind of an MEP standpoint on the software side, I've been using AutoCAD MEP for, as you can see, a very, very long time. Revit MEP since it was released for MEP. So back in 2005 when it was called Revit Systems and there wasn't even a pipe tool just yet. And then once Autodesk acquired the fabrication solutions from MEP software, that happened around 2014-ish, and then they started rolling out to the Autodesk partners around 2015. I started getting heavily involved with those. So I've been to a lot of shops all over the country. I've set up plasma tables, coil lines, you know, configured CAM software, the CAD side of things, the Revit side of things, so it can download into that, built out shop standards and so on. So pretty well versed in those types of workflows. Feel free to connect with me on LinkedIn. As most things, I'm not as active as I probably should be anymore, but hey, maybe you'll prompt me to be a bit more active. So as far as what I wanted to show today, I am on the technical side, as I mentioned, you know, formerly implementing these tools. So I'm not going to show, you know, fancy animated PowerPoint slides and things like that. I figured I'd really just get into the tools, you know, and kind of show you some of the different workflows. And if there's questions, feel free to throw those into the chat. And, you know, as we get towards the end, I'm going to leave plenty of time for us to address some Q&A, but we can go through that. So don't try to save it to the end, just log it in there and put it inside of there. And the story that I'm really going to kind of show and tell is, you know, from receiving a design model or an engineering based model, you know, what could we do from that? Could we maybe convert some of that into the fabrication content, or do we need to recreate it, redraw it? And you're going to see a lot of cases it's a bit of everything, right? You know, there's no easy button that's going to solve every one of those, but we'll see what that looks like coming from a design side, kind of build that out with some of the fabrication content, and then talk about what else we could do with those fabrication parts or those pieces there. You know, is that going to be taking it into the CAM package? So that could be downloaded, or maybe we're going to take that into the estimating side of things and look at it, or maybe we want to see if there's some coordination abilities that we can do with it as well. So with that, I'm going to get right into it. I'll give Revit a moment probably to catch up. There we go. All right, so this first thing I want to talk about before I really get showing tools and things like that is really the concept behind the fabrication content that we have at Autodesk. So When that acquisition of the software happened, like I said, around 2014, 2015, once it was finalized, we acquired 3 softwares. One was Fabrication CAD MEP, and that allows you to do your detailing inside of there. So you could draw sheet metal, you could draw piping, you could put in valves and components, you could spool, and it was real content. So for example, if I'm looking at, I'm going to just switch over to a service here. As I look at any of these parts right here, those are manufacturer specific components. All right. So CAD MEP, Fabrication CAD MEP lets you draw with those. And that was really one of the first times that we did that with Autodesk software. So if you used AutoCAD MEP or if you used Revit MEP, that content was, it wasn't a Nibco elbow or a Milwaukee valve. It was just an elbow, a flanged elbow. And so that allowed us to draw it from that drafting standpoint. The second software that was acquired was Fabrication EST MEP. And so EST MEP, which we will look at that a little bit, not in the primary scope of what it's used for, but a really interesting feature that we can leverage. But Fabrication EST MEP is its own standalone application. It lets you draw with those exact same fabrication parts and think of it as a true MEP estimating side of things, right? So a job comes in, I need to get a quick estimate put together. I can trace out a PDF if that's what I had, or if I had CAD files, I could trace those and I could generate some cost reports. Okay, and then it can be passed on to detailing and so on. The third software was Fabrication CamDuct. So again, the interface looks identical to SMEP, but it is also a standalone application. And this is what supports the communication with plasma tables, coil lines, and so on. So this is where the nesting takes place, right? Or if I need to build out the fittings, lay those out on a sheet of metal and have them get burned and label and print reports and things like that. So those were the 3 tools. So CAD MEP, CAD-based, right? SMEP for estimating, and then CamDuct for the CAM operators. Then around 2016, I think it was calendar year, is when it became enabled for Revit to use those exact same fabrication parts. Okay, and so we're sharing a common, it's called a database, but it's not a database, because if IT's in the room and you say it's a database, then they're thinking SQL, right? And they're like, okay, well, we got to set up a SQL server. No, it's really, even though it's called a database, it's just a giant configuration. It's a group of settings that are defining, hey, in my shop, if I'm going to do supply air, positive 2-inch, 4-inch, whatever, these are the types of fittings we use. We use slip and drive connectors up to this size. We use TDCs up to another size. And so you get to build out that shop standard inside of there. And then the same thing would happen on the piping side as well, right? So if you did piping and plumbing, you'd say, hey, we like to use these types of fittings by default. And maybe they are Nibco fittings or someone else, right? So you get to build that out. And that's really what that configuration is. So in that calendar year 2016, Revit became enabled to use all of those exact same parts. And there's a very key difference between Revit-based families and content and our fabrication parts. So for example, this is just regular Revit duct. Okay, it's just a normal duct fitting that's inside of there. So if I click on that, everyone's seen this that uses Revit on the MEP side, or if you just use it on the structural architectural, it's a family. I mean, families have parameters and drive geometry and all that fun stuff. So that's all that's happening right here. But one thing about content in Revit from an MEP standpoint is on the piping and the sheet metal side, Revit has no idea what a real connector is. Okay, so that little snap point right there, that's all it is. It's just a snap point, and it means that, hey, this thing can snap to this, and they go together. No matter what, they go together. So you can think of it as, if you had an incompatible piping service, let's say you were just running copper into a stainless steel line. If it was just Revit content, because they have snap points, they're going to connect. Okay, so it doesn't understand the logic of an actual connector. There's nothing that defines it other than size. Whereas if I am working with a fabrication part, And I'm just going to kind of drop one in here quickly. So if that's placed in there, this does have the logic behind the scenes that understands connections. Okay, so this is a bit of a different interface because it is a fabrication part within Revit, but there's connectors in there. And so that connector knows that it's a slip and drive connection. It knows that there's, a Pittsburgh seam on there, either small or large, depending upon your shop standard. If it was a flanged fitting, for example, or a welded fitting, because that's what I have in here. So if I went to this chilled water supply, and we'll just do copper. Right, so if it's a copper fitting, something we can actually see here. Actually, let's go welded. Right, so I'm calling out the fitting. When I drop this in, it's going to tell me that it's not visible, and my Revit users know why, because that thing is on a category that is not displayed right now. So if we turn it on, there's our pipe work. There's both of those fittings, right? So if I look at this welded fitting, again, if that was a Revit-based family, it would have no idea the type of connection, but this does have a butt-welded, beveled connection. So it understands rules that take place. So if another welded fitting hits that, it looks at those end conditions and it says, okay, well, there's a weld there, right? And it's got 1/8 inch or whatever. Just like if it was flange fittings coming together, it's going to understand that there's a gasket that goes there. There's a bolt set that gets incorporated. So if we're talking bill of materials, it understands that. So again, Revit-based family content has no idea about any of that information. So that's a very, very big difference between them. And I could argue that it should, because it would help us in like piping design, making more accurate connections and things like that. But honestly, from a design standpoint, we don't need that level of detail, right? I don't need to have all that information. I don't need to see the flange for every piece of ductwork. I certainly don't need to have data about bolts, on flange fittings, because that's just not what we care about in a commercial design, from that engineering standpoint. So that's going to be vastly different, okay? And at the same time, what does Revit-based content have that fabrication content does not? Engineering data. So this same, duct fitting here is going to have, CFM, velocity, friction. It's got those metrics, got that data flowing through there, whereas our fabrication parts, they don't care about that. Okay, so those are some things that I always kind of like to set the expectation that they are definitely different. And there is a big request that, well, hey, we want to model a high level of detail project from the start as engineers. So let's use the fabrication content, but then you lose the engineering data. So there is been a lot of requests to maybe enhance the fabrication parts to include some of that system data. So that's certainly something that, we're taking in consideration as well. Not in a, I'm not going to say that that's a roadmap based item, but that is submitted into our wish list and has been getting quite a bit of attention lately. So now let's see how we could kind of take what an engineer has provided or a designer and, and conveyed over inside of a Revit model. So obviously, this came from the Revit-based content, as I mentioned. And if I was a mechanical contractor or whatever my position was going to be, and I needed to detail this out, could I trace over the top of this? Absolutely. If I received a drawing file, a DWG, could I bring it into Revit and trace over the top? Yes, you could. PDF, yes, right? But I'm going to show a workflow that is possible in some cases, all right? And what that's doing is saying, okay, we've been provided this model, and the Revit users on the mechanical side, they're going to build out their own, project browser and all that stuff. That's why you can see there's some specific views that are defined out. But again, this is not working in your live project. So if I were to look at this and say, hey, I want to take that engineering ductwork and turn it into fabrication content. So if I'm selecting this, we have a design to fabrication tool. And what that's going to let us do is choose a service that we want to connect it to or convert it to, apologize. So services are what we have inside of the fabrication side. Systems are what we have in Revit. So if I said I wanted to switch this to a supplier service, again, if I was a shop and I had this built, SMACNA standards and all that, that's what it's going to use. And if you've seen this in the past, this conversion, we've been changing it the past couple of releases. So in 2022, it gives you some prompts, because before it would just take exactly the sizes that came from the engineering layouts and just convert them without even previewing those to you. If you knew for some reason you need to adjust sizes, we just give you this opportunity ahead of time. Now, when I convert this, and I'm going to do a couple iterations of this just to kind of show what could happen. So what that's going to go through and do is basically swap out the engineering ductwork, and it's going to put in fabrication parts. And it initially does a one-to-one swap of that. And what I mean by that is, if there was a straight inside of here, you know, it's going to put a straight there. If there was a bend, it's going to put a bend. Now, the fittings that it uses is based upon me, the shop owner, and how I've defined out my shop standard. So if I look at that supplier service, I'm going to see that it's going to go down through here and say, hey, what fittings are you allowing me to use during a conversion? Can we get a mute on Anthony Freeman's line? Could you mute your phone, please?
Lizzie will do it.
I will 100% do it.
Anthony Freeman.
Watch her like grab it with her bare hand.
Anthony Freeman.
Face first. Let me go find a knife.
Could everyone in attendance please mute their phones? Thank you. Okay, so it's going to look at all of these that are available and say, hey, what fittings can I use? So if I look at why did it not use a mitered bend there, because I have that being excluded when it does that conversion. So that's why it went to the next bend and it put that inside of there. So as a shop owner, you know, as I'm building this out, I get to define what fittings get used inside of here, right? So that's going to be the rule there. Even if from an engineering standpoint, if I were to undo that, you know, there was a round bend that was being placed, right? So if I undo that one step, there was a more of a long radius bend and it mapped it. Now, if I had that included to say, hey, that's our default, we want to use a square bend as a starting point for this every single time that we do it, that's perfectly fine. You can still swap these out as necessary if that's what you really wanted to do. So again, it's not using the engineer's suggested fittings, it's using yours. It just understands that, hey, when we make a turn right there, there is a bend required. So what bend do you want us to use? So again, it all boils down to kind of how you've got this defined out there. And again, as I mentioned, at any point in time, I could come in and say, hey, you know what, that's, we're normally going to use a miter bend, but in this case, we do want to use a radius bend. You know, I could swap that on the fly and no issue. Right, so you still get that control at the end of the day. Now, same thing at, if there's any type of, I'm going to say junction, right? So in this case, it was running perpendicular into there, so it's going to look at what type of T, you know, is being defined as my default. So again, that's looking down through this list saying, okay, well, you had a miter T gone, but you allowed a radius T. If that was excluded, it would just start moving down this list. It actually would have thrown in a tap there, which I definitely don't want. And it would have just kind of went through that logic. So we've got control over what is there, okay? Now, you can see that the boots are flipped. I'm not going to spend the time to flip those around right now, but just to show, yes, I could come in, flip these things, and they're the way I want them to be. Now, one other thing that's going to take place, I mentioned it's a one-to-one swap, right? So whatever that straight length of duct was, it's going to put a straight length of duct in that same place. Those from Sheet Metal World on this are looking at saying, okay, well, we do not fabricate a piece of duct longer than, it could be 411, 56 1/4, whatever your standard shop is, but we do not do that. So we understand that, and that's why we can pick our duct runs after they've been converted. And then we've got an optimized links. So what that does is it looks at my shop standard and says, hey, we break this thing up every 4'11" and go ahead and put a joint in there. right? So now that thing's going to go to, again, whether it's a plasma table or you guys have a coil line, or you've got it configured, hey, if it's, full lengths go to the coil line. If it's shorter than full length, it goes to the plasma. You can do that as well. So again, that shows that breakout for us. And then what I would do from kind of a detailing standpoint is I'm going to look at this and say, okay, well, is that good? I can still make some adjustments to this. Like in the case right here, I'm not going to have the guy burn that little tiny piece, just to have that. So this is where I make changes, right? It's not a big deal. I can grab it. I'm sliding that back. It's not the end of the world, right? That's what flex duct is made for. So again, you're going to have that final say so and being able to reroute this as necessary. Now, that was a pretty easy, simple one, just changes, right? The flip side of that is going to be what was drawn from a design standpoint will not convert because of, it could be a couple things. One, maybe we don't have the right fittings. Two, maybe there's not enough room for the fittings to go in there. So if we think about this run that I have here, I'm going to kind of grab this so you guys can see it a little bit easier. So if I were to look at this area, right, there's the return coming over, and then it was immediately going into a T. Okay, and I'm not going to do that. I'm not going to do that. And so this is just one of those cases of saying, hey, there's not going to be enough room if they try to do a flat out swap between these and kind of keep that positioning. Okay, it does its best to keep what's there, but if it can't fit, it will not convert it. And so same thing would happen if we were doing some piping and you drop down and maybe we're using a generic fitting and then quickly went flat again. If there's not enough room for the real fitting, it skips over it. So that's what we'll actually see happen with this one here when I do the conversion. So I'm going to select it all. And if I go design to fab, switch it to the return service, and then once we accept it, and it's going to let me know, hey, not all parts were converted. Check your service definition, which is basically just saying, hey, make sure you got the right stuff in there. If you do, then it's not your fault, right? But that's just saying, hey, we could not put that T in there because that was the one to be used. We couldn't put that T in there because there wasn't enough room for it. So it doesn't, like I say, it doesn't modify the design that was there. It like I said, it leaves it all intact. And if something just can't fit there, it just doesn't go. Now, if it's a mass amount of those, then just the run doesn't convert. But in this case, it's kind of a small one saying, hey, that's our, that was the issue that we had. So take care of it afterwards. And so what could I do? First, I could start with my, my optimized links to get that thing broken out, go back to my second floor, and then I could start to look at this of how I want to adjust it, right? And there's different ways of going about it. So for example, I could look at this straight piece and see what the length of it is. It's 2'5" and 9/16. I'm probably going to get yelled at for that. And I know if we bump that up a bit of a distance, we could save some space. So if I just did a move on it, let's say 5 9/16, 5 9/16 of an inch, right? So we're stretching it up, and then I can see what's left behind here. So if I wanted to clean this up, right, we could drag that over. We could go either direction with it. I'm gonna do a couple different ways. So there's a grip where I can just pull this thing if I want to pull it up. But again, that's just shifting the entire fitting itself. We don't want that because we'd be back in the same, original scenario that we had. So if I were to stretch this one down, that's one of the changes that we made in 22 also, is it behaves more like, I'll say, regular duct. And then if we look at what this return is built out as, the T's are turned off, I'm pretty sure, yeah, T's are off, but then a tap is there. So if I wanted to, just extend this, I could use a regular extend tool, right? And that's going to tap into it as well. And again, I could stretch out a little bit more to give myself some more space, right? But again, that just kind of shows I'm still kind of using what was presented to me from the engineering team and just kind of modifying as need be. And that's not always going to be the case, right? It could be that you got an updated steel package, or you got some of the other subs drawings, and the original layout just flat out isn't going to work, and it's going to take you more time to try to just convert it than just getting rid of it and redrawing. Okay, so those are all some decisions that you'll have to make on your side right there. Now we'll come back to the sheet metal here in just a few minutes, but I'm going to jump over to this mechanical room area here. So this has been modeled primarily with fabrication parts already, and I just kind of left out a little bit of an area here to show. So when we're drawing, we get really two ways to draw when it comes to the fabrication parts, and I actually wish we had this for the Revit-based families as well, but we can do what we call kind of like piece-by-piece modeling. So if I went to the chilled water return here, and the piece-by-piece modeling works great in kind of tight spaces and things like that, because, you know, if you're just doing that free flow drawing, you know, you're just kind of etch-a-sketching on the screen and picking spaces. Whereas here, if I say, hey, I know that when I come off this pump, I want a flange, then I want a 12-inch spool, then I want a valve. That's kind of hard to do in regular Revit drawing of piping. And I've done it for a really, really long time. So it can be done 100%, but this workflow is pretty nice as well. So what I would end up doing is choosing, you know, what flange I want to put in. Because again, the equipment is going to stay Revit families. Okay, so it's only what connects the equipment that would be fabrication parts. So you're still going to get pumps from wherever you get them from, air handlers from wherever you get them from, and so on. But just understand, again, as I mentioned earlier, Revit families don't understand what flange connections are. So even though this thing has a little fake flange drawn on it, a little baby flange, it doesn't know to call for a flange to get placed there. So you would need to put that in to get dropped as well. So if I said raised neck flange, and then when I touch on this, you're going to see the fab parts have different snap locations. So right now, that would be incorrect. That'd be welding a flange on top of a flange there. But you can see from the little tooltip, if I just hit the up arrow, now I'm going face to face on the flange, and it's going to stick that on there. And then after that point, I'm saying, hey, I want to put a little spool piece in there. So if I pick on that straight piece of pipe, all of our pipe, all of our duct comes in standard lengths to start. So based on the material, it would have that defined. If I was doing PVC, you know, it might be 10 foot, or this, I've got 20 foot, or maybe there's a 21 footer, but it's going to start with that. But that's where I can come and say, hey, I just want to do a little foot spool coming off of that, sticks it on there, and I could keep going, right? So this is that kind of like stick building that I mentioned. And then switching over, if I want to put a valve in, let's go down to a check valve. Same thing, I'm going to touch on that, and I can space bar to rotate that. If it's not super critical for this check, but we'll see it for the gate in just a moment. But if I were to snap that on there, all right, I'll end up fixing that in a second. So I stick that on there. Now I want a gate valve. Same thing, I'm coming off of there. And this is a Milwaukee gate valve. So that is actually something that can be found in a part catalog and has, you know, cost associated to it, install time, and all of that. So then again, I'm touching on that, getting a rotation for this thing to kind of clear. And then we get it in, right? And if I want to fix this one, again, there's my rotate. I can rotate that one as needed, you know, kind of match what I had. And then tying that up into there. So I could kind of manually put pieces in there. That would be a little bit more challenging to do. But we also have some kind of smart routing tools as well. So there's a route and fill tool, which basically is saying, hey, I want to go from this endpoint to that endpoint. And then based upon what's available to me in my piping service that I have, it could give me some different choices to go down between there. So this is saying, hey, there's 3 options, which I'm going to come back to this first one. But if I accept it, that went to some weird skinny, that variable bend. So if that was a cutback bend or something, which we don't need, and then a short radius, right? And so that's the 3 solutions it's going to give me. But if I go back to the first one, hey, we use a long radius by default. Go ahead and accept that, and that's going to complete it for me. So again, those are some connectivity tools that we can do to kind of speed things up, if we want to. And then on the plumbing side, so I'm going to do something similar here. Let's look at, I want to kind of touch on all three areas. Let's do level 1 plumbing 3D so we can kind of see both of these side by side. All right, so I've got my plan, and then I've got my 3D view over here. So same thing, you're going to end up choosing, a service that has been built out. So I've got this plumbing waste service. This is all using Tyler fittings. If you want to use someone else, that's perfectly fine. We've got more in the library, but that's just how this is built out. So at this point in time, this is still Revit-based families. It is sloped, which isn't always the case when we get plumbing models, but it is in this case. So let's see what would convert here. Okay, now a couple of things to look. Yes, I've got some combos in there, and I've got a sanitary T right there, right? Because we're going vertical on that, so that makes sense. But I want you to see what happens when we convert. Now, there is a lot of continuation of piping. Like this goes up to the second floor, does some other things. I'm just kind of ignoring what it's doing up there for the time being. But I'm going to select that run there, and you don't have to select entire runs. That's one of the mistakes that when I would teach this back in the day was when people wanted to convert, they would try to do this big massive area at once, or they'd do an entire floor and try to convert that to fabrication parts. Well, then you can't troubleshoot, if something's broken. So do it in a controlled environment. I could just window select, everything that's on that lower level if I wanted to. So I'm going to grab that design to fab. I'm going to choose that waste service, right? And it's all no hub fittings. Everything's 4-inch, and we'll accept it. And then once we see this convert, I'll point out what I started to highlight just a moment ago. And again, this is taking longer because these are connected upstream to a lot more fittings. You guys just can't see them. So here's a point saying, okay, well, not all parts were converted. And I could step through it saying, hey, there's 5 of them. And it's looking at those pieces right there. And again, that's what's upstream. So I could go troubleshoot that. But what I care about now is just kind of what's in my view here. So what I wanted to show is, think back to what I said earlier about the sheet metal. Even though there was a certain type of fitting that was placed, we don't match the engineer's fittings, okay? We just match that there was a T or an elbow or some type of junction, okay? And then it looks at our piping service to understand what should go there. We don't have the ability to say, hey, if you're vertical, put in a sanitary T. It just has to go down through this list and say, okay, well, where's the first kind of setup junction? Oh, it's a combo, right? If sanitary T had been higher up in this list, then a sanitary T would have gotten used in every single one of those spots, okay? But again, like we saw earlier, this did a pretty good job of converting. If that's the only one that I need to change out, I can select on it and say, okay, well, there is my sanitary T, right? Swap it out and just go from there. Again, I'm kind of leaving it generic here. I'm not, I don't have any carriers or anything, but you can see I can still swap that out. Just like if I needed a short radius elbow versus a long radius elbow, on the piping side, on the mechanical piping side. So that could all switch out, and that's what we've got. So it does keep that direction of flow, does keep that connectivity. And if we look on it, there is, an 1/8 inch per foot of slope on it. So pretty quick getting that converted. Now, let's say we just want to draw that. All right, so I'm going to get rid of the fancy conversion, and I'm just going to delete that stuff out. So similar to what I did just a moment ago, right, on the mechanical room, I could come in, pick that piece of pipe. How far do we want to come out? Because again, here it's at SCAD 40, so it's at 10 foot. I'm going to go 10 inches. Come out that distance, and I can work my way down there and do all of them, but I'm gonna do a different way for it. So I get that. I know I want a sanitary T, so I go find the sanitary T. And again, looking at that, insertion point of it, I'm just going to use my up arrow key to switch it to the correct spot, and space bar to flip that thing around. Right? Just like if you had a P-trap, you'd be doing the same thing as well, right? Hooking that up to the bottom of the sanitary line and swinging that thing around the direction that you need it. And if I wanted to shoot that bin up, I'm just going to go up a short distance here. So let's say I went 4 foot, give it that piece, touch it on that point, and it's going to go up. Now, I never like draw piping in 3D if I'm using Revit content, because everything sticks on like a plane. I'll change stuff all the time, but I don't do much drawing in here. But you can do drawing with the fab parts in these 3D views. Normally I'm in a section or a plan view. And then let's say we'll drop that 18 inches. So now I've kind of created that for myself. And if I just jump back to the plan view, I can see the same thing, you know, sitting over there. Right, so that's the same pipe, right? We can see it there. So let's just go to our routing tool. And we'll get into our plan view. We've got 4-inch, got my snap point. So now I'm ready to start drawing at this point. And I'm going to start it and then I'm going to undo it for a second. So I'm going to come straight out. And that's what's going to happen when you first do it, okay? Because the fact that it's seeing that, that snap point. So you can either do a couple things, like I could have shot that up, you know, higher out of the view, or go find myself a cap. Where you at? We'll plug you. That's fine. And that's a normal Revit thing too, right? That happens on fab parts and regular piping parts there. So that's just saying, hey, that's the open end that I want down there. So now I'll be able to find it. All right, so come over. Now I've got my start point. And so as I am ready to draw this, I could come from here. And then, you know, some that have been using Revit already may say, okay, well, that's, you know, a trick that I use instead, which this is usually going to be more common, is I'll probably do a section view to look through there, right? That takes the entire guessing game out of which, you know, which end that you're grabbing when you're wanting to do your modeling. So I'm going to shorten that section up. That looks good. Go to that view. Right, so then I could have just routed straight off of that thing from there the exact same way. Now with this, we've got the ability to turn on that slope, right? Or maybe I needed to drop down a little bit more. I could. If I turn the slope on, we're going to slope down, go 1/8 inch. And again, you can kind of do something simple here, run that out, and you can kind of see from the bent lines there, there's our slope added to it. And then if we wanted to finish connecting into it, again, I'm not going to try that from a 3D view. I really don't think that you can, but this is definitely where I'd go back from a 3D view. So if I look in here, now this particular, let's see how low did I drop down? I'm at there from that level. So let's drop down our viewing so we'll be able to see that pipe. Yes, let's go down just a little bit. Right, because we're under that slab there, so I'm on level 2, so I can't see anything down below it. There it is. So then if I just want to come out of this, now, if you just try to draw off of that fixture point, just understand that's regular, you know, Revit connections as well. So you can't shortcut off of that. You can't shortcut off of other fab parts. So you do have to start the routing tool or come off of it as well. Now, I'm not going to slope coming off the back of that. We can argue about that. But so if I'm going to come off, I'm going to snap to it and then just keep connecting down through there. So again, that's going to look at my defaults that I've got defined. And I can just keep running that out if I wanted to. And if we go back to our section view, right, we can see that's in there, getting way, way too tight there. So if we just want to drop that down, I'm just using my arrow key to drop it down. You know, I could play with the numbers through the elevation there as well. Something that doesn't get me yelled at. You know, I can do that as well. So that shows a little bit more of kind of free flow, modeling and going inside of there. Get rid of that cap afterwards. Don't need you anymore. And I can continue that upstream. So now let's look at, where can we go with some of this content beyond just kind of the modeling side. Now, I could tag this stuff. I could label it, sizes and everything else. It's no different than regular Revit content at that point in time. There's bottom of duct tags, there's item number tags and all that, which we could go through and do. But let's look at some other ways that we can kind of leverage the data or even leverage the information as well. So if I go back to our sheet metal, right, this is where we originated from. So a couple things on my selection. So let's say we'll do the supply. All right, so if I tab select to try to get my supply here, I'm going to filter out of everything besides the fab ductwork, right? So MEP fab ductwork. And normally I'll have like views kind of saved out to simplify this as well. So with that all being selected, one of the things that we can do is create what's called a fabrication job file. So this is going to be an MAJ file, and an MAJ file is what allows us to exchange between our other fabrication solutions. So if I was wanting to send this ductwork out to CamDuct, this is the path that I would go with it. If I do an export job file, we'll just throw this here. And typically you're going to name that, right? Your CAM operator is going to let you know what type of naming convention they like. So this is the second floor AHU, it's the first system, and it's supply air. Okay, they'll kind of communicate that. Do not send them an entire floor to try to manage. So that's going to say it exported out 29 parts. So now if I were to go to fabrication CamDuct, so this will be installed, CAM operator, they're going to be able to choose that job file that you just saved out. So if I do open job, and that was documents, right there is our MAJ file. And once I open that up, here's going to be a list of all of those fabrication parts. Now, a lot of times what they may do, if you just window select all of that and send it out, it is going to grab the round stuff, which is bought out, right? So they can go through and say, we're not going to, so we're not fabbing any of the round. Say we don't have a spiral. We don't do our own spiral. And then our shoes, which are round, we're going to get rid of those too. Now, again, if you just excluded those from your selection, then they wouldn't be included in there. So that's showing me all the items that it had inside of that particular system. If I want to look at this three-dimensionally, again, this is from the CAM side. They're going to come in here, be able to pull open that exact same thing. So there's that layout. You can even see where holes are getting burned out as well, right? Those were the branches that were coming off for the shoes. So we can burn out the holes. And then this is something else. So if anybody is on the call that, works on the CAM stations or anything, like, you get the final say so. Just like how I said, the design ductwork gets converted to fabrication parts, has all that metadata. And then when it comes inside of here, you're the last one, that's going to work with this before you send it to the table. So if you came into this and you saw there was an issue with something, here's all the properties that are still going to be available to you, right? It's got all that information associated to it. There's the connectors we talked about, the slip and drive, starts to expose the seam information. Remember, that wasn't important to a Revit user, but it is on the CAM side. So we can start to see that information. This had liner associated to it and some other things that go along with it as well. So you do get that final say so, if there was any changes that needed to be made with it. And then what that CAM user would do at this point is say, okay, well, this is good. We're going to go ahead and nest this. So they would have this configured based upon their preferences on the sheet metal, and it's going to go ahead and create and stretch out these flat patterns. So I can see I've got 2 sheets created, if I just want to open one of these manually, I'll close it down in a second. But we can see there are each of those straights. So those that haven't seen it before, so the straights are in two parts, right? So there's a folding notch right there. And there's a folding notch right there, right? So those get folded in twos and get tacked together and all that fun stuff. So these are all the individual fittings that have been laid out, and it's optimizing that metal based upon what's been given to it. So if that looks good, which they can still override it there as well, then they get to write a file, which is basically if I had a Vicon table, a Vulkan table, or something like that, that gets all configured to where when they write this file, it's going to format it essentially into a text file that knows how to communicate with those tables. You may have seen these if you've ever looked at some of the other CAM softwares as well. So basically, it's just coordinates, right? So it's given coordinates for that torch to pick up, sit down, where that thing's going to be burnt at, and it's just given the path there of the laser, right? So it's going around and finding that. All that stuff can be tracked as well. You can track machine usage. We can print out labels for each of these now that we've got, that's been pushed out. So think about, we've got a part label. I'll just do a preview here. So as that thing's getting burnt, right? I've got my label printer that's going. That stuff's getting printed out. I'm going to pull off the stickies and I'm going to stick it on the side of each of those inside of there, right? So we can see there's those particular parts. And these are all customizable too to match certain shop standards. And at the same time, reports are going to be flexible to be able to be ran to go along with it. So if I need to get amount of 16 gauge, it's being used, weight, tonnage, all that, we can generate reports from it at the same time. So that shows a push through from the Revit fabrication parts into CamDuct. And then if we wanted to see something, this is a little bit different than what we would do from the estimating side, but I'm going to go back to the mechanical room and I'm going to grab all of the fab pipe in the mechanical room. So get rid of that. And I'm going to do that exact same thing. I'm going to export that job file. And we'll see mechanical room. So that all gets pushed out. And then if I go into Fabrication S MEP, and I'm going to do an open job here. And then instead of grabbing that, which I could grab the sheet metal too. I mean, they're both MAJ files. Let's open that up. It's going to give me that same type of 3D view. Zoom to fit. Right, so there's all the piping that was in there. Right, there's the check valve and the gate valve that I put in there. But if I were to click on this valve, for example, and look at its properties, again, there's going to be a lot more information in this content that we don't see inside of Revit. So for example, there's an entire costing section that's associated to these as well. So it understands weight, understands Harrison price codes, if that's what we're using, install times, fab times, all this information is reportable as well. MCA rates can be incorporated to it. You can update the price list and use services that you typically use internally. But that is all information that gets exposed once we bring it into here, because at this point, if I want to do a quick estimating summary, right there it is. It's showing me based on the Harrison codes, we've got 51.6 is our total cost there. So if I wanted to switch services, if I was wanting to see what stainless cost would be, I could switch out a service for that. But that's going to give me those hard values right there. And again, to push that a little bit further, we have report interfaces that allow you to customize them. So for example, this breakdown, the tender one is pretty good. I like to show it as the default, but that's breaking down every single cost aspect of it. So there's my condenser water return, size 8-inch. Got 4 of them. There's my install times. There's my gross cost. All those being broken out, kind of itemized. There's the flanges, slip-ons, there's strainers. So again, a lot of different ways that we can capture that information. And there's that 51.6. So again, the fabrication parts really start to expose additional information, a lot more flexibility once we start pushing that stuff downstream. Now, if I was looking at this from a true estimator's approach, then this would not exist just yet. You could do that conversion and bring it in if you wanted to, but we also support importing PDFs. I'm not going to go through it, but you can bring in PDF files, DWGs, and essentially use those same drawing tools like what you saw me doing in Revit. They're a little bit different here because it's not Revit that you're drawing with, but you can see here's those same supply air service. If I was drawing the ductwork, we could put those pieces in and basically kind of trace over the top of it as well and get a rough estimate if we needed to. All right, and that brings me to the end of showing those workflows. Any questions? Nope. Jerry?
Yeah, I'm surprised the room's silent. I thought it, from my aspect, very, very useful information for me. There's a question from Brad.
Yeah, so tagging. So if I went to a tag tool, and depending upon what tags I have loaded, I think I've got bottom of duct and some others. Yeah, so there's bottom of duct. And again, keep in mind, these are all customizable and, as far as how you want them to look. Let's see what other ones I have in here. Yeah, it looks like bottom of duct's one I've got loaded for that. These are all driven by the scale of the view, right? So if that needed to change, obviously that's going to change normal Revit behavior. And best practice for coordination drawings. Can you elaborate on that, Brad? What parameters are you pulling?
Yeah, I'm just wondering, I don't know, can you hear me?
Yeah, I can.
I'm just wondering your best practice for tagging. We use fab parts and we have our own parameters that we've added to shared parameters. Assuming that's probably how you're doing it. I didn't know if you had any insights as it relates to fab parts and parameters.
What type of parameters are you having to create that don't exist?
My partner set up our parameters.
Oh.
I just know that we have our own set of shared parameters that relate to our fab parts that tie back into our configuration.
Okay. Yeah, it's so in 2017 there was only maybe 10 parameters you could tag by default, and then 18, 19 it started getting more and more, and it's very wide open now. That's why I'm kind of curious what else would be needed that would be missing, other than if you guys had some custom data that was in your fab database or something, because now it is pretty flexible. If I look at, we've got all the size information, insulation info, all the different elevations. Not saying there isn't any. I was just kind of curious what might be what you guys might be looking for. let's see, can the fab parts be used as part of the initial drawing in place of the alley docks? Yeah, I mean, we've got a lot of clients that are just using fab parts right from the start. The one thing that's missing, I mentioned, is going to be the engineering data. So if you were relying on Revit's duct sizing or pipe sizing, that wouldn't be there. You can still schedule all of your equipment correctly, because that's one of the things that gets misunderstood as well, is the fact that the fab parts and even the regular duct is just part of the connectivity. The system is still always there, right? So if I tab enough time, the duct system is still there between the equipment and the diffusers. So if I'm pulling any type of flow there or any of that information, I can still do that, right? So I can still get that info. It's just I can't click on this duct and say, oh, that's a lot of velocity. We need to look into this. You're not going to see that on that individual piece of duct. So that's kind of an internal discussion, but we do have a lot of clients that are just running with fab parts, and they're doing their own sizing methods.
Any other questions for Scott? He said he did have a 1 o'clock that he needs to jump off for a hard stop, so.
Yeah, I'm going from fabrication parts to MEP analysis. Load calculations next. All right. Well, yeah, if there's any questions that come in after the fact, or, if anyone watches the recording and wants to send those through, feel free to do so. Jerry, I'll probably be sending out a playlist of some short videos for you, if you could maybe forward to those that might be interested in those as well.
Yep, anybody that wants them, let me know, and I can make those available through Ann. So,
I could probably
appreciate your time,
add-
Scott. Thank you very much.
No problem. All right, everyone. Thanks for attending, and have a good rest of your week.